What is an algorithm? An algorithm is like a recipe for solving a specific problem. It consists of a well-defined set of instructions that guide the computer through a series of steps to produce the desired output. Just like a recipe helps you to cook a delicious meal, an algorithm enables a computer to perform tasks efficiently and accurately. Algorithm example: adding two numbers. To better grasp the concept, let's take a closer look at a simple algorithm, adding two numbers together. First, we take two numbers input. Next, we add these numbers using the addition operator. Finally, we display the result, which is the sum of the two numbers. So that's it. This is a basic algorithm, but it demonstrates the core elements of input, process, and output, which are fundamental to any algorithm. Qualities of a good algorithm. A good algorithm possesses specific qualities that ensure its effectiveness and usefulness. Let's explore these qualities. Precisely defined input and output. A well-defined algorithm clearly states what inputs it expects and what output it will produce. This clarity is essential for accurate problem solving. Clear and unambiguous steps. Each step in an algorithm should be crystal clear and unambiguous. Ambiguity can lead to confusion, making the algorithm difficult to follow. Effectiveness in problem solving. A good algorithm is efficient and effective among various ways to tackle a problem. It should achieve the desired result in a reasonable amount of time and resources. Universal applicability. Algorithms should not be tied to a specific programming language. They should be written in a way that allows them to be implemented in various programming languages, making them versatile and adaptable. Algorithm examples. Now that we understand the qualities of a good algorithm, let's explore some more examples. Finding the largest among three numbers. An algorithm that takes three numbers as input and determines the largest among them. The process begins by prompting the user to provide a values for these three numbers. Subsequently, a variable named maxnum is initialized with the value of num1. The algorithm then checks if num2 is greater than maxnum. If true, it updates maxnum to reflect the larger value. Similarly, it checks if num3 is greater than maxnum and updates maxnum accordingly. Finally, the algorithm displays the value stored in maxnum, which now represents the largest of the three input numbers. The process concludes at this point. Calculating the factorial. An algorithm to find the factorial of a given number, which is the product of all positive integers up to that number. The process begins by reading a positive integer, num, from the user. A variable named factorial is initialized to 1. Then, a loop iterates from 1 to num, multiplying the factorial by the current value of I in each iteration. This loop effectively computes the product of all integers from 1 to num. After the loop, the algorithm displays the final value of factorial, which represents the factorial of the input number. The process concludes at this point. Checking for prime numbers. An algorithm to determine whether a given number is a prime number or not. The process begins by reading num from the user. The algorithm initializes a Boolean variable is prime to true. It then checks if number is less than 2. If true, is prime is set to false and the process proceeds to step 6. If num is greater than or equal to 2, the algorithm enters a loop that iterates from 2 to the square root of num. Inside the loop, it checks if num is divisible by the current value of I. If divisible, is prime is set to false and the process moves to step 6. Finally, the algorithm displays the value of is prime, indicating whether the input number is prime or not. The process concludes at this point.